Hi. As I promised, I'm making a video on the reaction mechanisms. So, yeah, on the reaction mechanism handout because that one is the one that I kind of feel we didn't really have time to go through in class. So, activation, reaction mechanism. Now, so in short, and I really think you should be watching the cognitive videos. So in this case, a reaction mechanism is basically when you have a multiple step reaction. Okay, so you have a multiple step reaction, so a step by step account. Now you have all the intermediate stages, and essentially, what you have here, like for example, this overall mechanism. Okay, this overall mechanism this process, reaction process, actually takes a few steps. Now, I'm doing this solution based on this diagram and based on what we have, the material at hand. If you actually look it up on the internet about iodization of propanol, or it's also known in North America as acetone, this is a very well studied question, and there's a lot of proposals. Now, the thing is this: what I'm trying to get at is this is whole thing is a reaction mechanism. These in each of these smaller steps are called elementary steps. Okay, so mechanism for the whole thing. Each of these short steps are elementary steps. So now the slowest of the step in the reaction is called the rate determining step. So we talked a little bit about that before in class. And usually you use the slowest step to talk about the rate determining step. Because in some ways, how fast can the whole mechanism go? Well, it really depends on the slowest one. Um, it really depends on the slowest one. And this thing here, so in this case, using this particular example, A plus B gives you X plus C. In this case, because the because this is a rate determining step, keep in mind the rate will be K times the concentration of A times the concentration of B. Now, because this is one elementary step, one elementary step, so in this case it will be to a power of 1, it will be power of 1. It goes with the coefficient. That's with the elementary step. Don't confuse that as a whole entire mechanism. Now, molecularity is basically on the rate determining step how many molecules are involved. Basically, the less the less molecule there is, in some ways the easier it will be, right? Because there's not a lot of collision you need to have. So unimolecular is 1, it's usually breaking down. Bimolecular is 2, termolecular process is 3. Activated complex and intermediates, we talked about it in class. An activated complex is a transitional state. It's high energy, it's highly unstable. Okay, so this is an example of that. So when these two molecules collide, you have a activated complex or transition state like this. So where there's a temporary bond between this hydrogen and this nitrogen. Okay, and essentially, if you look at a potential energy diagram, as we said before in class, every time you have a peak, that's where the activated state or the activated complex is. Okay, these here are the intermediate. These here on the peak are the activated states. Now, in terms of how to do this part, and here are my answers. Now, if you look at it, it's always based on the slowest determining step. Okay, slowest step. However, there's a rule. If the slowest rate determining step is the second step, then you have to look at the first step, because after all, let's look at here. After all, for A to X to collide, you actually need X to be formed too. Or you need X to be formed first, which is in first step. So in this case, K here would be, you still need one A, but another A element. So it's A concentration of A to the square and B to whatever. Okay. So this, in this case, would be a third order reaction. Okay. Third order reaction, and it will be a molecular process. Okay. So look over the answers. Okay. So this one, same here, is the second step. First step, so it's just like this. This is the first step, so it looks like this. Okay. Now, coming back here, this example number 3. Now, this is the one that we talk about in class. This is for some of you, I talked about later on one-on-one a little bit. In class, when we're trying to, okay, so because for this question, write a mechanism for this reaction, determine the rate expression. Now, the thing is this, determining the rate expression. This is a really weird equation, simply because reaction, because we're looking at this right now. We're using this scale, and in class, what we talked about was, oh, wait a minute. If we look at in class, we talk about the individual activation energy. So in this case, this EA here is much higher than this EA here, and then compared to this EA is less. So in this case, because this EA is higher, EAA1 is greater than EAA2, greater than EAA3. Because of that, this here would be the rate determining step. Okay. Now later on, we kind of talk. I will talk with a number of you. Talk with a number of people. There seems to be a lot of ambiguity in terms of what. So basically, the overall activation energy. Now, this is why you need, for chemistry students, you really should have a good eraser and pencil. So now, while even though you have 3 separate EA for 3 separate elementary step, the overall EA activation energy is still from here, all the way to the peak, the highest point. So because of that, this is the weirdest part. If you're talking about overall EA, you're talking about from here all the way to here. But if you're looking at which one's the rate determining step, you look at the one which is higher. Okay, the higher EA of each elementary step. Okay, now I also looked this up too, and yeah, this based on this Nelson A-level chemistry book, it is also supporting the same reaction, where it's like, oh, the first step here is the slowest, and then the second step is the fastest. And then also there was, oh yeah, and then there's also another, yeah, there's another, um, yeah, and then there's another chemistry teacher also go with this one. So this one was the slow, fast. So in this case, this, so this one is the rate determining step. And so in this case, if we look at this mechanism or this elementary step, rate would equal. Now, if you look at it carefully, CHCO3, CH3, and then all of a sudden there's a hydrogen. Now, keep in mind it didn't really show up a hydrogen here, but there is a hydrogen. But if you, this is actually based on the acidic, hydrogen is actually a catalyst. So in this case, we put it here, you have something like this. And then here you go to this step, that's the second step here. And then third step here, you have this. So because this is a rate determining step, so this rate equals K concentration of this thing here, CH3CO CH3. Okay. Now, if you actually somehow, if you actually thought that this was the rate determining step, which seems to be a very common thought too, the thing is that even if this is a rate determining step, if you look at this equation, so this we even if you thought that this is a slow step, because this slow step depends on this previous step, so essentially you still kind of substitute it in here, so you would still get the same answer. So in this case, here this is a slow step, fast, fast. So with this mechanism, the rate the rate expression would be this. Okay, but even if this is the slow one, because this one, the slow step, we'll have to rely on here, it will still be the same answer. Okay. Um, so good luck on revising on this, and make sure you do a lot of practice questions. Have a good weekend.